Afternoon.
Afternoon.
Yes. So yesterday's class, we discussed two more sorting techniques. One was quick sort, and another one was the merge sort. So these are the two sorting techniques that we understood. So both quick sort as well as merge sort, they make use of the divide and conquer technique in order to sort the elements. Now what merge sort does is, it takes the unsorted array, goes for dividing recursively the unsorted array into the sub sorted array until no more further what splitting is not possible. So then we go for sorting the elements, and we merge them recursively until we get the sorted array. So that was the merge sort technique that we understood, and we solved one or two examples also. And the other technique that we understood was sorting the elements using the quick sort technique. So in quick sort technique, we take an unsorted array, so we mark the left and we mark the right. Okay, that is what we understood. So left is always initialized to the element which is present at the lower index, and the right is made to point to the element which is present at the higher index. And then we choose the pivot element. So we are going to choose the first element as the pivot element. And the whole idea behind the quick sort technique is very simple. So what we have to do is, once we choose the pivot element, so we are going to choose the first element as the pivot element, and next what we have to do after choosing the pivot element, you should go for since I choose the first element as the pivot element, I am going to start from the right end. Okay, I start from the right end, I compare the element which is present at the right end with the pivot element, and the whole idea is to arrange the elements which are smaller than the pivot elements towards the left side of the pivot element, and I have to build another array called as a right sub array by adding all the elements which are bigger than the pivot elements towards the right side. And this process we keep doing until the entire array gets sorted. So that is what we did. Yeah. So now the second technique. Do you people want me to solve one more example on the quick sort, or is it fine? Hello.
No, sir.
Okay. Now we'll go to the Radix Sort. So this is another sorting technique. Let me refresh it. Okay, now I got it. So one more is the Radix Sort. Now what we do here, again we take n numbers. So find the biggest number from them. Okay. So find the biggest number. Execute a loop including the function of Radix Sort for k number of times, where k is the number of digits of the bigger or the biggest number. Okay. So you got to take n numbers, and in that n numbers you should be finding the biggest number. After you find the biggest number, you have to keep executing the loop, inside the loop the Radix Sort, for how many times? K iterations, where k is the number of digits in the biggest number. Say for example, I have the array something like this, 10, and then 100, and then say I have 50, and the next element is 5. Say one more element I have 1250. Now in my unsorted array, this unsorted array, what is the biggest number? The biggest number is this. Okay, so 1250, and how many digits this has got? 4 digits it has got. So 1 2 3 4 unit place, 10 place, 100 place, and 1000 place. So 4 digits here. So now k is the number of digits that are present inside the biggest number. Right now this biggest number has got how many digits? 4 digits it has got. Now I should be going for running the loop for how many times? 4 times. OP people understood what k is?
Yes, sir.
Okay.
Yes, sir.
Take n numbers, find the biggest number, and then you're going to run a loop for how many times? K times. What is this k? K is the number of digits in the biggest number. Okay, next. Now we take the example now. So we take 10 numbers. The total number of elements what we are going to consider now is 10 numbers, and in this 10 numbers the biggest number is of 3 digits. So that means it has ones place, tens place, and hundreds place. The maximum, the third digit is at the 100th place. So the loop shall run for how many times? 3 times. Since the maximum number or the biggest number out of this 10 numbers is having 3 digits, so we got to run the loop for 3 times. Okay, 3 times for each of the digits place. So once for the 0th place, and next time for the 10th place, and next time for next iteration for the 100th place. 0th place first iteration, 10th place is second iteration, and 100th place we run the third iteration. So once you complete all these 3 iterations, so you should see the elements in the sorted order. Okay, so now what are those examples we are going to take? So this is the 10 number example which you have considered here. You can see 432, 8, 530, 90, 88, 231, 11, 45, 677, 199. So these are the 10 elements which are considered for sorting using the Radix sort, and you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. Now among this, the biggest number is this. So the biggest number is 677, and it is a 3-digit number. Correct? The biggest number what we have found here is a 3-digit number, and the loop should go for how many times? 3 times. So now I have found the value of k. K is equal to 3. K is equal to 3. Next what we do? So ones place, first I have to loop. So as I already mentioned, total number of iterations required are 3, and in the first iteration, okay, now I will be looping 3 ones place. So first iteration of the first loop or the first iteration is looping over the ones place. OP people are following?
Yes, sir.
Okay. Now that is what we are doing here. Okay. Now what I have done now, okay, so this is my original unsorted array. Now I have written, so these are the indexes: 0th index, first index, second, third, fourth, fifth, sixth, seventh, eighth, and ninth, and all of them are filled with zeros now. Okay, so we increase the count of n's value for every digit n at ones place. Okay, now what we do now? So just try to understand this. We increase the count of n's value. So initially they are all 0. Count of n's value for every digit n at ones place. Okay. Now how to do that? I'll show you. So this is what is my original unsorted array, and this is what I have taken, and these are the index values, and this is the current count value initially initialized to 0. Now if I come to this, now I am starting from this first number now. What is the first number I am having? 432. What is the digit at ones place? The digit at ones place is how much? 2. Hope people are following?
Yes, sir.
Since I have
Yes,
one number, so this is what the number which I have scanned right now from my unsorted array, and the digit at ones place of this particular number is 2. What I need to do is I just need to access this array which I have built, and initial value was 0, since I have found one number in my unsorted array which is having 2 as the digit in the ones place, I increment the count. Initially it was 0 in the previous this thing. If I come here, it was 0. Now what I am doing, since I have found one number where the ones place I have the digit 2, it has incremented. It is 1 right now. Okay. Next, I go to the next number 8. So the next number taken is 8. Now I go for increasing the count associated with the index 8. So initially the previous value associated with the count index 8 was 0. It was initially initialized to 0. Since I have found one number whose which is having 8 as the digit in its ones place. Okay. Now I am increasing its count and it has become 1 here. Now I continue. I move one more step towards the right, and the next element which I am encountering is 530, and in this I have 0 as the digit in the ones place. Now I should be going for incrementing the counter associated with the 0th index. This is 0. Now it gets changed to what? 1. So 1. Okay. Now what this basically doing is, it's basically tracking the count of the digits which are having 0. How many elements are having 0 as the what? Digit in its ones place, and how many elements within my unsorted array are having 1 as the digit in their ones place. Okay. Now I have encountered one element which is having 0 as the digit in the ones place. So this is incremented. Now I again increment my pointer. So one step towards the right, and the next element is 90. And again in this 90, what is that I have in the ones place is 0. Correct, no? So that means I have encountered the second number whose which is having 0 as the digit in its ones place. So now the count 0, what I am saying here, the count of 0 in the ones place is 1 right now. Now when I go to the next thing, it becomes 2, because there are two numbers which are having 0 as the digit in the ones place. I hope you understood till here. Okay. Next we increment this again 88. So the number which is starting the number 8 in the ones place, we have already encountered such number and the count is 1. Now we are encountering one more and the count will become 2. So 8, you can see the count is 2. That means, so there are two elements which are having 8 as the digit in their ones place. Now I continue scanning. Next 231 I am finding. In 231, so the ones place I have, zeros place I have 1. Okay. So again the count associated with 1 is going to be incremented and made as 1. So this is 1 again. Now we continue further again. 11 is the next element. Again at the ones place, 0th place, we have ones place we have 1. Again we increment the count associated with 1. So it is current value is 1 and it's going to become 2 here. So it has become updated to 2. Next is 45. So this 5 gets incremented by 1. So the count which is associated with the index value 5 is incremented by 1. Next 677. So this 7, the count associated with the index 7 gets incremented by 1. So you can see 7 is incremented by 1. Last is 199. So we have its count is incremented by 1. Now finally, when you scan all the elements of your input array and complete this, now what this is saying is, so there are two elements within your array which are having 0 as the digit in their ones place. And similarly, there are two elements, in your unsorted array which are having 1 as the digit in their ones place. So similarly, there is one element in the unsorted array which is having what? 2 as the digit in the ones place. Similarly, you don't have any element which are having 3 as the digit in their ones place, 4 as the digit in their ones place, 6 as the digit in their ones place. OP people understood this? Yeah? Yeah. Next, what we do, once you find how many elements are there, with respect to the ones place, okay, so you got to find the cumulative sum. Okay, so how to do that? We add the counts cumulatively. So this is 2 plus 2 4, and 4 plus 1 is 5, 5 plus 0 is 5. So I start from here, I take this 2. Okay, so since this is a starting element, I cannot add anything to this. For this 2, I can add this 2, it becomes 4. Now this is updated value 4, and to this 4 I add this 1 and I make it as 5. This becomes 5, and this is 5, and this is 0. 0 plus 5, sorry, 5 plus 0 is 5. This remains 5 itself, and again this is 5 plus 0, this remains 5 itself. That is what is the cumulative count we are doing. So finally when I do, so I get something like this. So you can just observe both is written. This is the count, and what you are seeing here is the cumulative count. You have to get the cumulative count. See, 2 plus 2 is 4. Hope you are following. Hello. So 4 plus 1. So this is the current sum. 4 plus 1 is 5. Next, this 5 plus 0 is 5, and again this 5 plus 0 is 5, and this 5 plus 1 is 6. 6 plus 0 is 6 again. 6 plus 1 is 7, and 7 plus 2 is 9, and 9 plus 1 is 10. So this is what the cumulative count what you got. Okay, we have converted just the normal count into the cumulative count. So what we did, let me summarize. So total number of iterations required are 3. Okay, in that 3 iterations, the first iteration we do by considering the element which is found at the ones position. Correct, right? Okay, so it is based on the digit which is present at the ones position. So and then we found the count of all the elements based on the occurrence of the digit at its ones place, and then we found the cumulative count. Okay, next, so this is what we got right now. So the cumulative count what is shown over here. Okay, okay, so now we go for, after finding this cumulative count, we go for sorting the number based on the ones place. Okay, now output 1, so it is still not written here. Let us start how to do it. So I will look here. Say I am starting from this from the left side, 199 I am taking. Okay, now this is what the array. Now I got to decide where this 199 goes based on this cumulative count what I have written. Okay, by using the digit that is present inside in the ones position. So 199 I am taking. In 199, I'll just go through this digit which is present at the ones place. The digit which is present at the ones place is 9. If I come to 9, so I have 10 here. I was having 10. So since array indexes, I will start from the 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the cumulative count what was here was 10. Now I'm just going to subtract 1 from this, because array indexes are going to start from this cumulative count. I'll be doing minus 1. Okay, so that is what this is, minus 1. So I'm not doing minus from this 199. I'm doing minus 1 from the cumulative count what is stored here. So I got this 9, so I come to this array, okay, because the digit which is present at the ones place is 9, and using this 9 I access this array. So here in the 9th index, the value which was stored here was 10. Yes or no? It was 10. Now I decrement that by 1. I decrement that by 1, so and it is 9 I get. Now I go for storing this 199 in the 9th position. Okay. So this is 0. Let me write, because I have not written indexes for this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I have identified, so the position of 199 as per the digit that is present inside the ones position is this. That is what I have found. See, if you are starting this index output index of the output also from 1, so you don't have to subtract. So directly then this will be the 10th position. It will, you say it goes here. Okay. So we'll go with this approach. Okay. Will output will start from the 0. So whatever the cumulative count you have, so from that you have to subtract 1. Okay. Next, I go to the next one. So the ones position I have how much? 7. Okay. I'll just go into this. So index 7 of this, my count array, cumulative count array, and I'll see what is the cumulative count. It is 6. So from this I got 2. So sorry, earlier how much it was? 7. I'm doing minus 1, it becomes 6. Okay. So the cumulative count was 7, and now here I found 7, and for the 7 it was 7 value. I'm subtracting that by 1 and it is 6. Now it goes to the position 6. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have the 677, sorry, the 677 taking the position 6 in my output array. Okay, people are following? Okay. Next is 45. Again I take the digit which is present at the ones place, it is 5. Now accordingly I go for accessing the cumulative count in my counts array. The cumulative count is what? It was 6 earlier. You can just, if you come here, it was 6, and from this 6 I am doing minus 1. I get it as 5. That means the 45 will take the position 5th in my output 1 array. So this is not the final output. So why I have written it as output 1? Because the output what I will be getting at the end of first iteration. Hope you people are following. So this is the output which you are going to get at the end of first iteration. We are still in the first iteration. Okay. Now, so 45 is taking the position. You can see the arrow. So it is not 231. So 45. So from this I am subtracting 1. So I am taking the element 45 and it takes the position 5. Excuse me for a while. Okay. So 0, 1, 2, 3, 4, 5. So the 5th index you can match from here also. 6, 7, 8, 9. Okay. Next. So after 45 the next number is 11. I have to find where the 11 will go in the first iteration output. So again the digit which is at the ones place is 1. Okay. Now it was 4. Now I decrementing this by 1, it is 3. Now 11 goes to the position 3. 0, 1, 2, 3. You can see 11 has taken the position 3, and this is 4, 5, 6, 7, 8, 9. See, all these things will confuse because there are many sorting techniques. It will confuse. So how to remember these things? You got to practice them 1 or 2 times. If you practice, then you can easily remember. If you don't practice, all sorting techniques will look like a confusing thing for you. You'll mix everything and you'll make a totally different sorting technique. So don't do that. Practice them well. So especially the selection sort, insertion sort, quick sort. So there is a possibility of students confusing in these three things. So you learn. So when I give you only the selection sort, you will be knowing the logic how it works. But when it comes to all the sorting techniques, and if you're asked one sorting technique in exam, all the logics, you're going to mix. So if you want to avoid this, so it depends on how much you practice. So more you practice, so all these confusions you can avoid, and it will also reduce. So the next number is 231. So 231 I'm taking. Then again, see the lower index is how much now? Not the lower index. The digit at the ones position is 1. Okay, I go to 1 now. So here 1. So from 1, this I'm subtracting. It was already. Yeah, 231 it is. So now, so it was initially how much it was? It was 4. Now when I inserted 11, it got decreased and it became how much? 3. So 11 got here to this position. Now it is 231. Again I am decreasing it by 1. Okay. Now you got it as 2. Now 231 takes the position of 2. Understood, right? So if you just observe the digit in the ones place of 231 and 11 is both are 1. So when I took 11, so the cumulative count was 4. 4 was decreased from 4 to 3, and 11 took the position 3. Okay, 11 took the position 3. This is the third position. 0, 1, 2, 3, third position. Now again 231. So is having the digit 1 in its ones place. Now the cumulative count, it was already decreased, and it was 3 in the 1 index in the cumulative count array. So now the 3 is again decremented, and it is 2 right now. Now 231 has taken the position 2. 0, 1, 2. Okay. Next, after 231, the next is 88. Okay, 88 I've already written. I've skipped one step here. Now 88, you tell me where will the 88 go. So the digit is 8 here. Okay, so it matches with this, and the cumulative count is also 8. Okay, so 8 you got to decrease it by 1. I think it's already done. What was the cumulative count of 8? Original cumulative count of 8, it was 9. So 9 minus 8, it becomes how much? 9 minus 1, it becomes 8. Okay, so you can see 88 is taken the position 8. This is the 9th position, and this is the 8th position. So and then we have the 90 going here. Okay, so 90, 0 it is. So I think for 0, the previous count was 2. Now it is decreased from by 1, and it is 1. So 90 has taken the position 1. Okay, so next is 530. Similarly, where it is taking here, and then 530 where it is 0 again. Okay, it is taking the position 0. You can see here 530 has taken the position 0, and then 8 it is. 8 again take the position, you can see here 3, it has taken this position. Now how, where is 8? This one is 8, right? Yeah, 8. See here, so the previous cumulative count of index 8 was 8, and that is decremented by 1, and it becomes 7. Now 8 takes the position 7. So position 7, and we are left with last element, that is 432. So 432 is taking this position. Hope it is clear. Yes, man. Replay. Now the array, the final array which you get as output from the first iteration, is sorted according to the ones place. Okay, so just keep observing the ones place now. So don't look into the tens place and 100 place. Just focus only on the ones place. So this is 0, 0, 1, 1, 2, 5, 7, 8, 8, 9. So we have this shorted on the ones place digit. Okay, so this is shorted on ones place digit. Now we go to the second iteration. Okay, the numbers are already shorted based on the ones place digit. In the second iteration, so we repeat the same process what we did now for the digit which is present at the 10th position. And in the third iteration, we go for repeating the same thing for the digit which is present at the 100th position. Okay, so now 10th place, so we are performing the loop 2. Now input for the loop 2 or the second iteration is what? This array now. This array is considered as the input. So we don't take the original unsorted array as the input to the second iteration. Remember, so output of the previous iteration is input to the next iteration. Hope you people are following. So output of the first iteration which shorted the unshorted array using ones place digit is the input to the next iteration, that is the loop 2, where we are going to short based on the tens place. Okay, now again I got to build my count array. See, everything I've reinitialized it to 0, but now the input is the output of the previous iteration. So this is the output of the previous iteration. So now I go for looking into the digit in the tens position and update my count array. Okay, so initially everything is made as 0. So I am not showing this. I have written everything at once now because you know how to do it. So let us start. Okay, let me start from this side itself. So this is 3. Okay, so I go to 3. Okay, so this will so the count is 1. So this is the final count which is already written. So count is 1. I take this 9. I go here and the count becomes 1. So don't look into this. Look into this what I am writing. So next is 3. See, this was the count was 2. Now I have obtained one more number which has the digit 3 in the tens place. Now the count is not 1. It gets incremented and it becomes 2. So sorry. Count is 2. Okay, next is 1 year. So this is the first time occurring. So tens place I have 1. So this is 1. And then here 3 again. See here. And this count gets incremented to 3. And then 4, this count is 1. And then 7, this count is 1. And then 0, this count is 1. And then 8, this count is 1. And 9, this count is 2. And this is what you are seeing here. So 0, okay, where I wrote, sorry, instead of writing here, I have written here, this 3 I have to write here, 3 right, so 3 I have to write here, that is a mistake I have done. Is it confused for you people, or you know it? Hello, okay. So this 3, instead of writing here, I have written here, sorry. So this is 0, because we don't have any element having the digit 2 in its tens place. I have a look here. Okay, this is 3. So and same thing is written here. And this is 0. And this is 8, no, don't take this. We don't have anything. Okay, this 0. If there is a 0 before the digit, let us not consider it. And this is still 0. Don't look into this also. Or in other words, don't write this 0. It's not required. Okay. So 0, 1. This is 0, 3, 1, 0, 0, 1, 1, 2. OP people understood this? Because a 0 before the number doesn't have any meaning. Correct, right? This is not necessary also. Don't do it. Is it clear? Okay, next go for doing finding the cumulative count. Okay, I think there is a mistake, then this one is required, sorry. So there is a mistake, don't look into it. The 0 because we balance it. Okay, so when I'm taking, so in this ones place I had, tens place was not there, so in tens place I can go for writing it as 0. Yeah, so this I have to take it as 1. Sorry, what I wrote was correct. This I have to take it as 1. Okay, now the cumulative count. So 1, this remains the same. 1 plus this 1 plus 1 is 2. 2 plus 0 is 2. 2 plus 3 is 5. 5 plus 1 is 6. And 6 plus 0 is 6. And 6 plus 0 is 6 again. And 6 plus 1 is 7. And 7 plus 1 is 8. 8 plus 2 is 10. So remember, if there is no tens position in the element, then you write it as 0. Okay, and next in the third iteration when I am doing, since there is no 100th position in this, I will be writing it as 0. And again I will write one more 0 here. 0 0 8 I will make it, and here I will put a 0. 0 4 5 I will do it. 0 1 1 I will do it. 0 9 0 I will do it. Okay, people understood? Okay, next you sort using the ones position. Okay, now I'll just try to write here itself. Okay, now let me start from here. Okay, I'll start from here. So 9 in the, what you have to observe now is the tens position. I have 9 here. I'll come to this. Okay, I have to subtract 1 from this. Okay, so let me write the 1 2 3 4 5 6 7 8. Oh, it is not writing. 8 8 9. Nine is the digit. I check my cumulative this thing, and it is 10 here. 10 minus 1, 9. That means 199. I think if I write here, you can't see. Let me write it below. So 199 takes this position again. Okay. So next is 88. So the tens position I have 8. If I just check this, what I have, 8. 8 minus 1 is 7. So it takes this position. Which position? 7 position it will take. 88 comes here. Correct, no? Okay, next I'm done with 88 and 199. Now I take the 08. Okay, 0, tens place I have 0. Now if I come here, it is 1. 1 minus 1 is 0. So I have 08 taking the 0th position. Okay, next 8 is also done. Now I take 6 7 7. So tens place I have 7. When I examine this 7, it is 7 here. The cumulative count is 7. 7 minus 1 is 6. Now 677 takes the position 6. 677. Next, this is also done. I continue. I take 45. 4 is the digit in the tens place. So it is 6. For 4 it is 6. The cumulative count is 6. Minus 1 is 5. That means 45 takes the position 5. 45 takes this position. Next, 45 is also done. 432. Okay, 3 is the digit in the tens place. For 3 I have 5. 5 minus 1 is 4. Okay, That means 432 takes the position 4. 4, 3, 2. Okay. Next, this is also done. 11. 1 is the digit in the 10th place. So for 1 it is 2. 2 minus 1 is 1. Now the 11 takes the position 1 in my output 2 array. So this is output 2. This is again still not the final output. So output which I am going to get at the end of the second iteration. Output 2. Okay. So 11 is also done. Now 231, I take 3, again the digit in the 10th place. For 3 it is, so this was already decremented. Sorry, I should have written that. So, 3, nothing has happened. Okay. So 3 it is 5. 5 minus 1 is 4. No, I think I made a mistake. I should have updated them. Okay. So the cumulative count, let me check whether it is correct. 1 here. So this is 1. Okay. 1 plus 1 is 2. 2 plus 0 is 2. 2 plus 3 is 5. It's correct. So I think it should. 3 here. I add 3 here, right? 1, 3, 432. So 3 I am getting, and this should be decremented. Correct, right? This is already decremented. Okay, people are following? See, 432 has taken the position 4. How it took the position 4? So 432 10th place is 3, and 3 index value is 5. We decrement this, right? So it becomes 4. It becomes 4, and then here we have added. Now again 231 I have. Let me decrease the count. 3 and this is 4. 4 it was this. This is also decreased. And how much it is? 5. So because I have to update. And this is 1 second. Let me start from here. 9, right? This is decremented and 9. And 8, right? This is also decremented and it is 7 right now. And this is 8. Sorry, 0. This is also decremented and right now it is 0. And this is 7. 7. This is decremented and it is 6 right now. And this is 4. Okay. Where is 4? 4 is here, decremented and it has become 5. And this is 3, decremented. 5 is decremented and it is 4. Now again, this was 1 and this is decremented by, and it is 1. Next 231 I have encountered 3. If I come here 3, and what is the value? 4. This will be decremented by 1 more, and we get it as 3. And we have 231 taking the position 3. 231. OP people understood? Next is 231 is also done. 90. Okay. 9 is the digit in the 10th place. So I come to 9. So we decrement this by 1 more, and it is 8. That means 90 takes the position 8. 90. Next is 530. So digit in the 10th place is 3. So 3 is this, and it is already 3. Now this is going to be decremented by 1 more, and it is 2. That means 530 takes the position 2. 530. Okay. Now by the end of second iteration, so you have your input array
ಮೇಲ್ ಐಡಿ ಅಂತ ಸಾಫ್ಟ್ ಕಾಪಿ ಬೇಕು ಅಂದಿದ್ರಂತಲ್ಲ, ಹಿಂದೆ ಮೇಲ್ ಐಡಿ ಬೇಕು.
ಆಯಿತು. ಬಟ್ ಇದು ಯಾಕೆ ಹಿಂಗೆ ಹಾಕಿದ್ದಾರೆ?
ಇದರ ಸುಮ್ಮನೆ ನಮಗೆ ರಿಸೀವಿಂಗ್ ಹಾಕಿ ಸರ್.
ಅಲ್ಲಲ್ಲ, ಇಲ್ಲಿ ಸ್ಟಾಫ್ ಆಫ್ EC ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅಂದ್ಬಿಟ್ಟು ಇದು ನಿಮ್ಮದು ಮಾತ್ರ ಅಲ್ವಾ? ಇದಿಷ್ಟು ನಿಮ್ಮದು. ಇದನ್ನ ಯಾಕೆ ಹಾಕಿದ್ರಿ ಇಲ್ಲಿ? ಇರಲಿ.
ಮೇಲ್ ಐ ಡಿ ಬರ್ತದೆ
ಯಾರ್ದು?
ನಿಮ್ಮದು ಸಾಫ್ಟ್ ಕಾಪಿನ ಬಂತಲ್ಲ ಕಡೆ ಸೆಂಡ್ ಮಾಡ್ತಾರೆ.
ಯಾರು ಕಳ್ಸೋದು ಇದು? ಹರ್ಷವರ್ಧನ?
ಇಲ್ಲ ಸರ್, ಇವರು ಎಚ್ ಡಿ ಕಳಿಸಿ.
ಹಾಂ, ಇದಕ್ಕೆ ಕಳ್ಸಿದ್ರೆ ಆಯಿತು, ನಂಗೆ ವಾಟ್ಸಪ್ ಮಾಡಿದ್ರು ಆಯಿತು. ಇಲ್ಲ, ಇದಕ್ಕೆ ಕಳಿಸಿ, ಮೇಲ್ ಮಾಡಿ. Now at the end of second iteration we have our element sorted in two positions. So ones position and tens position. Just observe the last two digits, 8, 11, 30, 31, 32, 45, 77, 88, 90, 99. We have them sorted with respect to ones position and tens position. So now in the third iteration, hope you understood till here? Okay, in the third iteration, so I am not writing it again fully. So this is what the third iteration results you are seeing. So you know what you have to do in the third iteration. You have to take the digit in the, so you take this empty array, initialize everything to 0. So just take the digit in the hundredths position. So go for appropriately counting and then find the cumulative count. This is what you are seeing is the cumulative count now. Okay. So in the third iteration, what I do, I'll put a 0 here, and I put a 0 here also, and here also 1 0, here also 1 0, and here also 1 0. Okay. Now based on that, we are going to sort. Take this 199 again, I think. Okay, and this is what we are writing, tens position and ones, the array sorted in based on the tens position and ones position. This is the array. Now we are going for tracing based on the 100th place now. So 100th place, as usual, see, this is what the count I get. Okay. And this is what the cumulative count we are getting. Now then we go for sorting it based on the 100th position. So just observe now. So 199. Okay, let us take this. Okay, so 1 is the digit. Let me go to 1. So this gets decremented by, so this is not 5, it becomes 4. That means 199 takes the position 4. 0, 1, 2, 3. Oh, I don't know whether the cumulative counts are correct or not. So 1 second. Oh, this is written wrong here, and this is already decremented, I hope. Okay, so this is what I have to see. This is what I have to see. See, 199 if I take, so 1 is the digit, so 1, and this is going to be decremented by 1, and it becomes 5. So now 199 will take the position 5. You can just observe here, 0, 1, 2, 3, 4, and 5. 199 has taken the position 5, and this is the correct position of 199. And next is you take 0. So 90 has got in the 100th place 0. Okay, the 0. And if I come here, so to the cumulative count, so it is decreased by 1 and it becomes 4. That means 90 takes the position 4. Where it is? Here. 0, 1, 2, 3, 4. 90 is in the position 4. Understood? Like this we do it. Any doubts? Okay. And this what you are seeing, don't take this into account. Okay, so use this, use this one. So based on this, these are the correct values, and this is what you get it. Okay, so and this was the initial array, and this is what the sorted one you are getting at the end of the third iteration. Okay, so this is the radix sort. Okay, and after this there is one more sorting. Okay. that is sorting by address calculation. Okay, address calculation sort it is called as. So Radix Sort is important. So practice it 1 or 2 times. Take your own array and practice it 1 or 2 times. So that is the end of the Radix. And next what we have is the address calculation sort. Okay, so I think it's not possible to complete this now. It will take some time. What we will do is we'll stop here, and again afternoon I am continuing. So 3 to 4 class also I am taking. So 3 to 4 class I'll complete this address calculation. This is the last sorting technique. Okay, I think 3 plus 2 5 and 6 7 total 7 addressing sorting techniques you have understood, and this is going to be the last one. Okay, and after this, in the 3 to 4 class, we'll go for looking into the implementation part. How we'll start from the bubble sort, selection sort, insertion sort, quick sort. So we'll see the implementation part. If I complete the implementation part of this, so we can go to the sorting techniques. We are not going to discuss too many sorting techniques. We discuss only 2 things. One is the linear sorting, and another one is linear searching. Another one is binary search technique. These 2 we'll discuss, and then what we are going to discuss is the hashing technique. So on hashing technique there is one more lab program. So I cannot complete all these things today itself. Today, after completing in the afternoon class address calculation sort, so we'll just go for looking into the implementation part of all this sorting techniques. Okay, and then in the tomorrow's class we'll understand the searching techniques, and then we'll get a start to the hashing technique. Which one? This address calculation uses the linked list. You require the linked, and rest all uses the arrays. So using the arrays, what we are going to discuss. But for this address calculation chart, you require the linked list. Hello, yeah.